Hello YouTube, I'm Ephraim225 and today I have something different for you all. In the past I have created a number of fan games and I also have a number of original game projects which you can find on my GameJolt page. Link to that will be in the description if you're interested. For most of these game projects, I use GameMaker Studio to create them, and recently I've gotten back into working with GameMaker Studio 2, and I am now working on a brand new game project. And since I am learning a number of new tricks and techniques to make the development cycle a whole lot easier for myself, I thought it would be very beneficial to everybody if I show you how all of these tricks and techniques work in a series of YouTube videos. This is not going to be a super beginner level series of videos. However, for fairly experienced GameMaker users, I am hoping that through my videos, I can make some of the more trickier things to implement in GameMaker a lot easier for you to understand, and that will hopefully make game development a lot easier for you as well. So, today's video is going to be all about platformer physics. We're going to go through tile collisions, which I struggled to understand at first, but they're actually really useful. We're going to be talking about soft platforms, which is a term I invented. I'll explain what those are. And then we are going to talk about slopes and moving platforms, which I understand are tricky to implement in GameMaker, but I believe I've gotten it working fairly well. So I'm going to show you how I did it. So let's get right into it. This is the step event for my player object. There are a number of functions here. I'm going to take you through each one of them and show you how they work. First up is floor check. The purpose of floor check is simply to determine if the player is standing on a block or a floor or other object that you can stand on. So I have this variable on ground that simply determines whether or not the player is standing on something or not. It starts at 0, and there is going to be a series of checks for objects that the player can stand on, and if the player is indeed standing on something, on ground is going to be set to 1, and that lets the rest of the functions know you're standing on something. You can do things like jump, slide, and all of that stuff. So, the first thing I'm going to explain is tile collision. Now, if you've ever worked with GameMaker in the past, if you've made a platformer, for example, you've probably done this for your level geometry. You've created a block object, you've pasted it all throughout the room, and that's going to count as the level geometry's hit detection. And then to make the levels visually distinct, you've probably pasted tiles on top of those block objects. And that works, except for the fact that anytime you want to change the level geometry, you not only have to move around the block objects, you also have to change the tiles, and it becomes a bit of a hassle to have to do that all the time. So it would be far easier if you could just use the tiles themselves as your hit detection, and you can. This is a fairly recent addition to GameMaker as far as I know. I don't really pay attention to the change logs, but something that you can, in fact, do is use a tile layer as your hit detection. And the way you do that is in your room, you want to create a layer that you're going to have all of your tile collisions on. Then you can add your tiles. And then in this floor check function here, what I've done is you can use layer tile map get ID. This will take one of your layers and store its ID to a variable, which is what I have done here with variable underscore tile map. The string that you input here is simply the name of one of your layers. So on every map, I'm going to have a layer called collision, and that will contain all of the tiles that I want the player to be able to collide with. And then you can simply feed it into the place meeting function in place of an object. You can simply put that variable here. It's really nice. So here what I've done is if place meeting at x, y plus 2, because we're checking just below the player for a tile, if that checks out, then on ground will be set to 1. False speed, which is my vertical speed variable, will be set to 0. And since I am using a 32 by 32 tile set, I know that if the player is standing on a tile, they are always going to be at a multiple of 32 with their y position. So I set y to round y divided by 32 times 32. This little bit of math is very useful, by the way. You'll want to keep it in mind. By rounding the variable divided by 32 and then multiplying it by 32, I'm essentially snapping the player to the nearest multiple of 32. And then I subtract 0.1. This is simply because I ran into an issue where the player would sometimes get stuck in the floor, so I just placed them just barely above the floor in order to make that work. By the way, my player object's origin is at the very bottom of its bounding box. So what you're going to want to do is you're also going to want to offset the Y position based on the origin of the sprite. If, say, your origin is in the center, you'll want to account for that, basically. Now there's a bunch of other floor checks in this function, but I will take you through them as we progress through the other functions. So, going back to the player step event, the next thing that I do is player input process. This is the function that gets what buttons are being pushed by the player, and then having certain actions be taken based on whether or not the player is standing on something or not. For example, if they're in the air, obviously they can't jump unless you have double jump implemented. So I'm not going to take you through player input process because whatever you're doing in your game is probably different from whatever I'm doing in mine. But in the future, I may make a video about player input processing because there are some advanced things you can do with that as well. So the next function we'll look at is wall collision. These four functions here, they all handle what happens if the player is in the air and about to land on a platform or object. Floor check just makes certain the game knows whether or not they are standing on something. So let's go over to wall collision now. And this is probably going to look a little bit familiar. The standard for handling collisions in GameMaker these days is to use place meeting with x plus walk speed, which is the horizontal speed of my player object. And if a object, or in this case the tile map, is detected, then the game will use this while loop right here to move the player as close as they can get to the wall or tile without actually touching it, and then walk speed will be sent to 0. And then we do it again for vertical collisions as well. The only difference here is that we're using Y instead. And also, I have this little check here. I automatically set on ground to 1 if the player's fall speed was higher or equal to 0. If it's less than 0, then the player is going upwards, and they should probably not stop moving if they hit their ceiling on the... hit their head on the ceiling, excuse me. You could also use this function to do something such as Mario hitting a block. You would use the this function here to check for the object and whether or not the player is going upwards instead of downwards. And if Mario was going upwards when he touched the block, then naturally he would hit the block and something would happen. So that's something you can do. So this is very basic. We're simply taking the old place meeting method and then feeding the tile map later into it instead. Now, the thing you want to keep in mind with this is that if the game detects a tile in a cell that the player is moving to, the whole cell is going to count as having hit detection, even if part of the tile is empty. So if you've got half a wall, then going into the cell where the tile is located is going to count as a collision, even though it doesn't seem like part of the tile should be collided with. Now, I will link in the description a blog post by a guy named Pixelated Pope. I can't believe that's his username, but there it is. And he came up with a way to make the tile collisions precise, i.e., if it doesn't seem like there should be a collision with a tile, then there won't be. And, it's fine if you want to use that method. I just think it's rather complicated to work with. So a link to that will be in the description if you want to go see that for yourself. Let's move on here. Next up, we have soft platforms. So if you've ever played a modern Castlevania game, I say modern, but these were like DS games, so they're not really modern. If you have played a quote-unquote modern Castlevania, you've probably seen those platforms where you can rise up through them, but you can't fall beneath them unless you duck and press the jump button, right? So how those work is that we are going to go into floor check first. So since we're talking about soft platforms, I also want to explain that you can actually use multiple different tile map layers for different purposes. So I've got a collision layer for general collisions, as I just explained, and I also use a separate layer for the so-called soft platforms. So that's a thing you can do. You can even create all kinds of other different layers for things like platforms where you want ice physics or things like that. So to explain about soft platforms, since we only care if the bottom of the bounding box of the player object is above the soft platform or not, we're going to use position meeting instead of place meeting. Position meaning only cares about the specific pixel that you input into the function. Place meaning will check the entire bounding box of the player object against the tiles for the purposes of collision. Position meaning just cares about one specific pixel. So I'm going to put in the bottom bounding box of the player in place of the Y position. This way, I can also check for false speed equaling 0. And if both of these come out to true, then it will be the same as in the previous function. On ground will be set to 1, false speed will be set to 0, which is kind of redundant because false speed was already checked for being 0 or not, and the player will be snapped to the correct position. And in the physics part of it, let's scroll down here. Again, we're using position meaning and using the bottom of the bounding box plus false speed plus 1 to check for the tile, and it does the same thing. Snap the player to the correct position, set false speed to 0, and on ground equals 1. The important thing is we're checking for false speed being greater than 0 and there being a platform at the specified pixel perfect position. So that will cause us to only actually detect a collision when we are falling on the platform from above, not when we're rising up from below. That's how that works. So soft platforms, and the function where the player can duck down and jump beneath a platform is part of player input process, so I won't go over it here. Next, we're going to talk about slopes, and these are a tricky thing to implement in GameMaker. I had to fiddle around with it quite a lot in order to get it working right. So the first thing I want to explain is that I use a stair object for the slopes, or a slope object rather, I just named it stairs. I use a separate object and not a tile layer because, again, if you want tile collisions to be precise, go check out Pixelated Pope's blog post that is linked in the video description. I just think it's too much of a hassle to implement, so I use an invisible stair object in order to implement slope collisions. The sprite for that object is simply a 32 by 64 pixel rhombus, and I have this here. This is a collision event between the player object and the stairs. It is simply a sanity check. If the player ever actually collides with the stairs, I want them to move upwards until there is no collision with the stairs, because if the player gets stuck in the stairs object, that's going to be really annoying to work with. So I use this sanity check in order to correct that if it comes up. So again, let's look at the floor check. This is very simple. If place meeting object stairs, on ground is set to 1. Very simple. You don't need to do anything silly with this because your Y position is not necessarily going to be snapped to the nearest multiple of 32 when you're dealing with a stairs object. And now the physics of this are where things are going to get tricky. First of all, vertical collisions with the slope object are very similar to the tile collisions that I used earlier. If place meeting Y plus false speed object stairs, then get as close to the stairs object as possible without actually touching it, then on ground is set to 1 and false speed is set to 0. Now, the horizontal collisions are where this gets tricky. So, if place meeting X plus wall speed object stairs, so what we're going to do here is that if I simply use a normal collision function for the stairs, then even the slightest bit of height on the stair object is going to trigger a collision and then the player will stop moving. So what we need to do is we need to check slightly above the stairs object for a free position. So what's going on here is variable Y plus equals 0. And then we have this loop that basically checks for a empty spot. And if it finds one before a certain point, i.e., absolute value of walk speed, then what happens is the player's Y position will be set to that empty space. So it creates this illusion of moving upwards through the stairs. And if no empty spot was detected, then it's a simple, just stop moving, stop the player from moving. You can actually use this in any block object that you want, and it'll be fine. And in fact, if you use a rhombus-shaped sprite for the stairs object like I did, you could actually stretch out the stairs and you would have this nice smooth hill with this function. Very, very nice. Now, let's see here. Going down the slope is also an entirely different thing. So now, instead of checking for an open spot above the player, we now need to check an open spot beneath the player. So it's very simple. First, we check if there's a stairs object beneath the player. Otherwise, we're not using any sort of stair physics. And then we check if there is not a stairs object where the player is going horizontally. And we also need to check that there is not a collision tile. So I also check for that as well. So, same idea here, except we're now going downwards instead of upwards. While there is not a place meeting x plus walk speed, y plus y minus with object stairs, and y minus is less than or equal to the absolute value of walk speed. By the way, you can change this here. This is basically the maximum amount of height that the player is allowed to travel. And in this case, it's equal to walk speed, so I set it to that. But you might experiment with changing it around a little if things don't look like they're working super properly. If y minus is not less than or equal to absolute value of walk speed, then the player is moved to their new position and the movement is nice and smooth. So that's how the slopes work. There are a couple of quirks to it. Like, I noticed that if you walk towards the slope at a certain speed, then the player object gets stopped completely. I don't really know what's going on with that, but it happens very rarely, so I'm not going to worry about it quite yet. So now we're going to talk about moving platforms. This is another thing that is very tricky to implement. So I'm actually going to look at the physics for it first. The physics are very simple. I've chosen, by the way, to make moving platforms similar to the soft platforms that I just mentioned. You can rise up through them, but you land on them from above. They don't have, they're not like a solid box that you can collide with. And I decided not to do that because if you want to have a moving platform that can maybe smash the player into a wall or something, I found that tricky to implement myself. So I'm just going to keep platforms as similar to how they usually are in, say, Castlevania, for example. So variable instance equals instance place. We're using instance place here. This checks using the bounding box of the player for a collision with another object and then returns the ID of that object. I then store it into a variable because I need some extra information about the particular object that I am colliding with. So that's what I'm doing here. Instance place, y plus fall speed, object platform. The platform object is a separate object, and I'll explain a little about it as we go. So first, if inst is not equal to no one, if no platform is detected, then this function returns no one, which means there's no object. So first I need to check if inst is not equal to no one so that the game knows to ignore all of this. And then I check for the bottom of the bounding box minus false speed is less than or equal to inst dot the top of the bounding box plus 2. This calculates whether or not the player should be able to land on the platform or not from above. And naturally, since the player is going to be landing from above, we need false speed to be greater than 0. And if you want to be able to turn on or off a platform object under certain conditions, then I also threw in this variable, inst.isHit. And if it's false, then the player cannot collide with the object platform. So, if all that checks out, then first we're going to set the player's Y position to inst.boundingboxTop minus 0.1. Like with the function where I snap the player to the nearest multiple of 32, this just ensures that the player stops on top of the platform object. And you are also going to want to account for the player's origin, the sprite origin. And if the player lands on the object successfully on ground equals 1, this stuff here is for the properties of a particular type of platform that I use in my game. And then set false speed to 0. Now, the tricky part is, how do you get the player to move along with the platform when it is moving? It's simpler than you might think. So, we're going to go into floor check now, because this is where I perform all of the checks for moving the player along with the moving platform. I suppose I need to scroll down a little bit. So again, we check for a platform object with instance place if inst is not equal to no one and the player is detected as being on top of the platform, as we just went over in the physics script. So set on ground to 1, and then, this is the important part. To move the player along with the platform is very simple. All you have to do is use x previous and y previous. These are built-in variables that track where the object was in the prior frame before this one. So by using x minus x previous or y minus y previous, you can calculate the distance that the object moved in a single frame. So by moving the player along that exact same distance, then the player will be moving along with a platform object. It's nice and simple. Now, we also need to check the position that the player is going to for a collision tile, because I don't want the player getting stuck inside of the collision tile. So that's that. It's much simpler than it seems. And then after that, the last thing to do in the floor checked object is check if the player is not on the ground, and if they aren't, then these variables, which track whether or not the player is ducking or sliding, get set to 0, because in my game you can't duck or slide while you're in the air, right? Okay, so that is all of the floor check function. I don't know why I returned something. I don't really use it that way. And that's everything in the physics function, but there are a couple more functions here. Gravity and movement, these are very, very simple. Gravity simply does the usual increasing the gravity if you are in the air, because naturally you fall faster and faster the longer you are in the air. And then the movement function just applies movement to the player based on walk speed and fall speed. You'll notice that I have a variable here called global.bullet_time. I'm not sure if I'm going to use this variable in the future, but I thought it would be best to explain it here as well. So, you know how in Breath of the Wild, when Link pulls out his bow in the air, everything around him slows down as he takes aim? That's what they call bullet time. It actually is a movie term, if I'm not mistaken. But the basic idea is, normally bullet time is going to be set to 1, and if through some sort of effect or ability I set it to something like 0.5, then suddenly everything is going to be moving at half speed, and it doesn't change the frame rate. You might expect me to just change the frame rate in order to simulate time being slowed down, but that's going to look choppy, it's going to look really awful, so doing it with the global.bulletTime variable is nice and simple, but you have to be careful with it, because literally every variable or movement that objects make has to be multiplied by global.bulletTime in order for the effect to come out well. Because, like, otherwise you're going to have a bunch of objects moving at different speeds if you forget to multiply something by global.bulletTime. So that concludes my explanation of how I implemented slopes, moving platforms, and tile collisions in my game, and I also explained a little bit about the global.bulletTime variable. So, if you found this video helpful, thank you very much for watching. Leave a comment, like, and subscribe, and I'll see if I can do more of these in the future. I would very much like to. And I will also be showing off my game in the future as well, so stay tuned for that. See you later, everyone.